All right, so the non-conservative work is the work done by the difference in pressure. Now that means that the pressure up top was pointing with the motion, so it was a positive work being done. But the pressure down here at the bottom of the pipe is pushing against the motion. So is it a positive work or negative work done by this pressure? It would be negative. So if work is pressure times volume, we just determined that just a minute ago, if work is pressure times volume, then the work done by P1 would be positive P1 times volume. And remember, the volume of the fluid that's flowing in all parts of the pipe is the same. So the pressure on the volume at the top of the pipe is the same as the volume on the bottom of the pipe. Same volume. Minus, because it's pushing against, it's doing negative work, the pressure at the bottom times the volume that pressure is applied to is equal to, now kinetic energy, what's the equation for kinetic energy? I can't remember. 1/2 mv squared. So 1/2 mv final squared, and my final position was 2, so I'm calling that V2, minus 1/2 mv1 squared plus change in potential energy. What was potential energy? mgy, so mgy final minus mgy initial. That's pretty. All right, well look, there's mass. Do we measure fluids in mass? What do we use for fluids? Volume. And how is volume related to mass? Through density. Density is mass per volume. So mass is density times volume. Let's make a substitution into this big nasty energy equation. So we'll have P1V minus P2V is equal to 1/2 rho volume times V2 squared. Love that, don't you? 1/2 rho volume times V1 squared plus rho volume GY2, trying to emphasize my volume, rho volume GY1. It got bigger and bigger, didn't it? All right. What's really cool about this equation now? Holy cow, is volume multiplied by every single term on both sides of the equation? So what can I do? I can divide by V on both sides. So that's really awesome because look, we were about to have volume and velocity right next to each other. And how many of you make your volume and your velocity look different? Not enough of you. So I'm crossing out with my little lightsaber the volume. All right, so that means that I'm left with P1 minus P2 is equal to 1/2 rho V2 squared minus 1/2 rho V1 squared plus rho GY2 minus rho GY1. All right, so let's go to all the ones on one side and all the twos on the other side. So I'm going to have P1, then I'm going to add this 1/2 rho V1 squared term. I'm going to add rho GY1, and then on the right side I'm going to add P2. I have the 1/2 rho V2 squared, and I have rho GY2. And that, all written out, and that is Bernoulli's equation. Big old Bernoulli's equation. Now the cool thing about this is that if there is not a height difference, you can still have a speed difference because of different pressures. Okay, think of a syringe. P1 might be the pressure that your thumb is applying to the plunger.